Dear participants and dear colleagues, in my role as the president of the International Astronautical Federation, it's my great pleasure to welcome you today to an exciting new session, part of the IAF GNF Space Conversation series. I would like to take this opportunity first to thank the entire IF community for their support to the Federation in these unprecedented times of the pandemic, and for participating to the IF spring meetings that were held virtually last week. And I was extremely happy to see all the IF committee members connecting from all the different time zones. We have today a new opportunity to share, connect, although still virtually, and this time for a very exciting webinar, a part of this IAF GNF Space Conversation series. So today's session is organized and sponsored by the German Aerospace Center, DLR, one of the Federation's oldest and most active members. IAF member since 1985, DLR will focus today on aerospace technologies in support of humanitarian aid. So humanitarian aid organizations are increasingly seeking technology support for their work in crisis and disaster management. And DLR was one of the first to launch new initiatives and look for new technologies to support various humanitarian organizations all around the world. So in today's panel discussion, DLR scientists and engineers will show how they work in interdisciplinary teams with humanitarian organizations to advance technologies and also strategies for better and more effective delivery of humanitarian aid around the world. But before we dive into this really extremely interesting topic, it's my great pleasure to give the word to Professor Hans-Jörg Dittus, member of the German Aerospace Center Executive Board. Thank you very much and enjoy the session.
Can you hear me now?
Yes.
Okay.
Please go ahead.
Thank you. Thank you, Pascal, for this nice introduction. And I'd like to thank you and the team of IAF very much for giving us this opportunity to present DLR's activities and technology developments for worldwide humanitarian projects. Helping people and governments in their daily problems of humanitarian aid, like in healthcare and food security and migration, I think is our challenge, our common challenge and our common obligation. And often society is not even aware of how much space research is present in everyday life and offers solutions to problems that all concern all societies worldwide. At the German Aerospace Center, we in DLR, we take the task of putting our research into applications for the benefit of society very seriously. And so the humanitarian aid projects we are presenting in this panel now, in this next hour, show how our scientists are developing solutions that help humanitarian aid organizations to help people in need. And our scientists are experts in these fields, in their fields. And then, let's say in Earth observation, for example, with the processing and evaluation of satellite data to generate information for a wide range of applications. And here DLR has many years of experience and expertise. Our engineers can design greenhouses that are able to provide astronauts in space stations with fresh food, but even, and that's the idea, help people on Earth to get fresh food during drafts. And our robotics experts can equip rovers so that they can travel as autonomously as possible on foreign celestial bodies and send information back to Earth. And this, of course, can be applied to a lot of problems on Earth as well. Images captured by drones during overflight can be transmitted in real time to the ground, where they can be immediately evaluated and used. So this is what is DLR's research is based on. And we try to use this for humanitarian projects, humanitarian aid worldwide. But what exactly helps aid organizations that want to supply people in hard to reach areas with food and medicine? What are their exact needs? Where are the gaps that we can close with our technology and approaches? For our Humanitarian Technologies project, we have brought on board the very experts who know this as well as our scientists know their research areas. We approached the national and the international humanitarian aid organizations and asked, what do you need? What do we need to consider in developing our technologies so that it meets your needs exactly? Among others, we have now won the World Food Program of the United Nations as a partner, the organization Human Rights Watch, the German Federal Agency for Technical Relief, and the German Red Cross. And we have given our scientists very precise framework conditions in order to develop in a goal-oriented and effective way. So first of all, the projects must be completed in a, let's say, 2 years time frame at the latest. So that means they should not run over many, many years. They should be done in very short time. Second, our institutes will work together in an interdisciplinary way to pool competences. And third, the projects are carried out in cooperation with the users. And fourth, the goal of all the projects is what a pilot application of the developed technology is with a pilot application of the developed technology. That's very important, the last point. Now we have selected 4 projects which we like to present today and which are currently underway. Maybe I can go a little bit into with one sentence in the detail of this, in the details of this project. With the Meepa, it's the first one. DLR is developing plant units that can be used to support the supply of the population, for example, in crisis regions. And here DLR is applying its expertise on greenhouses, which has already successfully tested in Antarctica and will be developed for further moon bases and stations outside the Earth. Data for Human, another project. We process the data products of our Earth observation satellites specifically for the questions of the aid organizations. Then we have the Drones for Good the Drone for Goods project, which equips the unmanned area vehicle with algorithms to deliver goods safely to those in need. And last but not least, there's AHEAD, which uses technologies from space robotics, for example, so that vehicles can transport goods as autonomously and teleoperated as possible to inaccessible areas or areas that are dangerous for aid workers. So now I like to hand over to my team, to the DLR team for Humanitarian Technologies for this single presentations. Thank you very much.
Thank you very much, Hans-Jörg, and thank you very much, Pascal, for this introduction and for giving us the opportunity today to share our experiences and our background in the Humanitarian Technology Initiative. My name is Stefan Vogt, and I'm the coordinator of this initiative at DLR. And it is my great pleasure to be with you today here and to moderate this afternoon session. And of course, it's also my great pleasure to have my fellow panelists here with us and with me to discuss the projects, which are also listed here on the screen. And while we do that, you may come up with questions. You may want to learn about certain specific aspects of this, which of course we try to introduce these to you as deeply as possible in this time, but you may engage through the Slido system. So you can use this QR code here, or go to www.slido.com, and you can add the code for the session here, IAF GNF series, and there you can post questions, which we get then later on in the Q&A session at the end will be trying to answer. And now it is my great pleasure to introduce to you the panelists. So I will go in the order of appearance here and in the order of our discussion. So we have Daniel Schubert with us here. He has a background in industrial engineering and with an emphasis on airspace and production techniques. And he's with our Space Systems Institute. And so it's a pleasure to have you with us, Daniel. Secondly, we have Anne Schneibel. She's an environmental scientist by training and focused in doing her PhD and also her work since on remote sensing techniques to support humanitarian aid and to sustain food security. Thirdly, we have Nina Merkle. Nina is a mathematician by training. She is currently focusing, and since quite some years, on the fusion of multi-sensor remote sensing data, and in particular on deep learning techniques. Anne and Nina are both working in the Earth Observation Center of DLR, and working very closely with me. I'm also based in the Earth Observation Center at DLR. And last but not least, we have Armin Wedler. Armin has a background and long year experience in mechanical engineering, and particularly in robotics. And in many projects and activities, he has been focusing on the aspects of field robotics. And yeah, it's great to have you all with us here today. And now, without further ado, I suggest we go into the projects. And I would like to start with Daniel. Daniel, I mean, you are working now on food supply systems for astronauts. How did you find out in the first place that your systems and your approaches may also be adapted to humanitarian purposes?
Well, thank you, Stefan. Well, the idea was quite obvious. We're providing food for the astronauts once they're on the planet or on the moon surface. And the idea was quite obvious to say, we're doing this in such a harsh environment like on Moon and Mars. Why not doing this on Earth and provide fresh food to people in need, especially in harsh environments like you have perhaps in deserts or in dry areas. So what you see here, and I want to quickly show you our project. This is our background. We're designing greenhouse modules for space to basically provide food for the astronauts. You can see here, this is our latest design for a moon greenhouse system on the right side. And this system can not only provide food, but it can also contribute to the air revitalization and water recycling tasks that we will have in future habitats. Our main research facility that we are operating right now is the Eden ISS facility. It's you can see it here in the lower left side. This is a test greenhouse system that is presently standing at the Neumeier Station 3. This is the German research station in Antarctica, and we're producing here fresh food for the overwintering people during their isolation phase. Next slide. So what was the idea to transfer our knowledge that we are doing for the last 10 years with respect to extraterrestrial greenhouse systems? We wanted to transfer this to crisis scenarios. So what is a crisis scenario? It could be earthquakes, civil unrest that usually result into refugee camps. We have floods or droughts. So there are all those different types of crisis scenarios. And what do they all have more or less in common is that the local and the national food supply chain is disconnected. And usually this is not only disconnected for a couple of weeks. I mean, it depends on the country. It can also, sometimes it's disconnected for months and even years until the food supply chain can be restored. And our goal in our project is to provide fresh food for the people in need until the local infrastructure is restored. And how do we do this? Next slide, please. So we have the Meepa system, as you can see on the right side. It's a small system that 2 people can carry. It has a support unit and a deployable structure. You can see here the airframe. We have a water bladder that is that you have to fill up with fresh water. And then on top of this, we will have a so-called seed cultivation mat. And in here, we will later on cultivate our fresh produce. We do this soilless. So we are not using any soil to do so. So we call this a hydroponic cultivation process. The overall system is solar powered, and it's a semi-closed loop system. So basically all the water is restored and recycled, so that we are not losing any water to the soil. So what you see here, this is basically the deployment scenario. So we can fit up to, until now, we can fit up to 75 units in a standard 40-foot shipping container. And the idea is to transport this container into, let's say, a refugee camp or into a crisis area. And then we will hand out, or this is the vision, we will hand out those units to the people in need. It can be easily, as I said, deployed, and then should be automatically, more or less automatically, start producing fresh crops. So in total, in one 40-foot container, you can see 75 units. This results to roughly 530 square meters of total growth area. And we did a small calculation for lettuce. We can more or less produce 3.5 tons every 4 to 6 weeks for the people in need.
Okay, thank you, Daniel, for this introduction and for introducing this system, this Meepa system. So actually, which of the examined and studied technologies, like the hydroponics in particular, or the seed cultivation in particular, or the whole system, which of those things are you actually seeing the largest potential for actual implementation with the humanitarian partner systems? Will it be parts of it, or will it be the whole system?
Well, for now, it's the whole system that we think it has a main advantage. But the hydroponic solution itself inhabits a huge benefit. The reason for this is that what we found out when we talked to our stakeholders, the international aid organizations, they said that, for example, refugees are not allowed to do agriculture in the refugee camps. This is usually the host country is not allowing the refugees to do this, because as soon as they start using the soil and doing agriculture there, it has a character of a settlement, and they don't want to have people to settle in those refugee camps, because it has something like a steady state, so to say. But doing it hydroponical, where the seeds are, or where the roots are not touching the ground, this is fine for them. So this is one reason why a hydroponic solution is a benefit for those, let's say, medium-term cultivation processes.
Okay, that gives even a political reason, or even a reason for accepting a temporary refugee installation, a refugee camp, and that makes sense. Yes, thank you, Daniel, for now. I think we will come back during the Q&A session on the Meepa system, and I would now like to hand over to our second project, to actually Anne Schneibel. And Anne, Data from the World Wide Web, from social media today, give us a wealth of information and give us possibly a situational overview, also partially, on humanitarian situations. In the Data for Human project, you combine these with other data sources like remote sensing, satellite imagery. Actually, how do you do this fusion?
Yeah, thank you, Stefan. Yeah, indeed. So when you think about web information, you think about a vast amount of information. And for us, it becomes more and more valuable. And now thinking about a crisis event, it can sometimes take up to a couple of days until the satellite acquires an image, and or even until we produce an analysis product for the organizations. So this is something where web data can come into play and provide more valuable or timely information beforehand. But it's not only about time, it's also about space. So thinking about the satellite acquiring an image, there might always be areas that are not covered by the satellite, for example, due to cloud cover or to the geometry of the overpass of the satellite. So in addition, we can use web information to complement the information on the ground. So from a spatial and from a temporal domain, web data can really complement the information from the satellite. But not only during the crisis or at the point when a crisis happens, web data can also be important in the aftermath of a crisis. And that's something where satellite data is also still lacking its potential, because web data can provide us with information about social unrest or looting, for example, in the aftermath. So yeah, you're right. One of the focus points of the Data for Human project is the meaningful combination of data from different sources. And so I'm really happy to present the project for you here today. So the Data for Human project also has a proper name, and that is Demand-Driven Data Services for Humanitarian Aid. And what you can see here is that we work mainly with 5 users, and these are Human Rights Watch, the German Red Cross, the Humanitarian OpenStreetMap team, the United Nations Development Programme, and the World Food Programme. And the project itself, it arose from discussions between these users and DLR scientists about what kind of data and what kind of geodata those users would need most of us to be meaningful for their work. And so when it came to the discussion, there were some requirements that all of the users named. And that was that the data has to be up to date. And this is, for example, where we can use web data for. The data has to be reliable. People on the ground do not have time to assess the accuracy of data in case of a crisis. It has to come in different scales depending on the size of the crisis. It has to be easily and straightforwardly accessible. They want us to use a multi-source approach, so combining data from different sources. And of course, it has to be user adapted, depending on the user's needs. So as you might imagine, due to the variety of users and the variety of their demands, we produce different output depending on what they need. And that can be crisis information in a digital or an analog form, then it would be a map. It can be that we demonstrate our methods, or it can be that we provide them with prototypes, for example, with codes that they can further develop. Next slide, please. Yeah, and so this is the framework of the project. And I would now like to give you some insight on what we actually do. And we have different case studies, but there are some points that are important to all of the users and to all of the case studies. And these are, again, we combine data from different sources. You see that on the very left image here. This is an example from the flood in 2019 in Mozambique. And for this case, we use web data, and more specifically, we use data from news portals and Twitter data to see how this data could complement the work of the organizations on the ground and maybe provide them with more information for their relief actions. Second is we always adapt state-of-the-art methods and further develop them. And in the second image, you see the example of the refugee camp Moria on Lesbos. As you might remember, last year, September, there was a large fire and many thousands of people were left without shelter. So we did a mapping approach there, and what we tried was to use artificial intelligence for the mapping. And we actually found that artificial intelligence can speed up the mapping process significantly. And I'm actually very happy that Nina will present some more of her work later on. Third, of course, no data is, or every data has to be accessible for the users. Otherwise, it's worthless. So what we want to achieve is that our data can be quickly and reliably accessed. Now, as you might imagine, it's not that straightforward as you think. Given the example that we produce a flood product, like a flood layer, and we want the user to access that, it has to be pushed through whole DLR, through all the security barriers, and there are a lot for good reason. So what we want is that the user gets this information as quickly as possible. And we do so by providing it as a web service. So the user gets informed via GeoRSS about the availability of the layer, and then can access the layer directly and pull it to their system, for example, to a GIS system. And last but not least, and this is very important for the project, is that we provide support for the user's specific case studies. So there is not that one big goal in Data for Human or that one big method that we develop, but we work specifically for the user's needs, no matter what it is. And here on the very right-hand side is an example from Human Rights Watch, where they wanted us to check again for the displacement of the Rohingya people, mainly taking place in 2017. Now, as you might see, it's very small scale, and the burned settlements are sometimes consist out of a couple of houses. And the time period we were regarding was 10 days. So that's very small scale and a very short time period. And nevertheless, we do that because that's a demand from Human Rights Watch. And I really want to emphasize that this is the big advantage of the project, that we finally have the time and the framework to address the humanitarian organization's needs in detail, no matter what it will be. Yeah, thank you.
Okay, thanks Anne for this insight into the Data for Human project. Just one question. You're focusing on specific test areas and case studies here in pilot regions. So which criteria have you applied actually for the selection of those?
Yeah, so as I mentioned, the case studies are given to us by the users. However, and we apply our methods on those case studies and we adapt them further. However, we are still researchers, so we always aim for transferability of our methods. And that's why we chose one big case study, and that is the flooding in Mozambique in 2019 due to the cyclones Kenneth and Idai. And the reason for that is that many humanitarian organizations were involved there, and we can now assess their workflow and see what kind of data they would have needed to support their relief actions. And the other reason is that what was already mentioned is the project consists of different teams from different disciplines. And with this case study, we want to see how to combine the results from different teams, from different disciplines in the most meaningful way. And this will be, it will be kind of a case study that we then can transfer to future crises.
Okay, thank you, Anne. Great, and I'm sure there will be questions coming back to you maybe during the Q&A phase of this panel. And I would now like to move over actually to Nina. Nina, you're working with the deep learning and AI techniques in the Data for Human project, as well as in the Drones for Good project. In the Drones for Good project, actually, you're applying AI techniques for safer operation of those drones in the humanitarian domain. Actually, how do you support this safe drone operation with AI? Please tell us a bit more about that.
Yeah, thanks, Stefan, for the introduction and your question. So my team and I, we are trying to support this project in two different ways, or two different scenarios that we defined to investigate for this project. So first of all, after any kind of natural disaster or humanitarian crisis, everyone first tries to get like a good overview about the current situation that you have on site. For example, you want to know how many people are actually affected by this crisis. And here we are trying to support humanitarian organizations by valuable information that we can get from deep learning approaches. Here, for example, you see us in the middle, a satellite image over the city of Beira in Mozambique after a cyclone happening in 2019. And we showed already for the data for human project that with the use of AI approaches, we can actually extract valuable information out of a satellite image, for example, about the building or the road network. And in case we even have like a pre and post disaster satellite image pair, we can also do something like a damage assessment of buildings, or we can see if maybe something in the road network changed after the disaster. In contrast now to data for human, where we're getting the data from satellite providers. In Drones for Good, we are also applying a technology that we developed at DLR, which is helping us to acquire the data by ourselves. And here you can go to the next slide. So in the last years, we developed a camera system called Maxar at DLR, which can be equipped on either our own drone or also a drone from a local drone provider. And with this camera system, we can actually fly over a region of interest. We can acquire image data, send it in real time to the ground, georeferences, and provide first responder with such kind of digital map that you can see here in this animation. And this data that we acquire can really help the first responder to get a better overview about the current situation on site. Of course, when you imagine that you acquire data from a large area, which is maybe covering several square kilometers, it takes quite some time and it's maybe difficult to identify the hotspots. And here we want to bring our AI into place, that we provide the first responder with additional information layer that they can put on top of the image data. And for example, that they can identify more easily maybe region where we have a lot of damaged buildings or where we have maybe larger crowds of people in the scene. This covers the first scenario that we investigate in Drones for Good. And in a second scenario, after we have a better overview of your scenario, the current scenario, you can start planning several operations. And we investigate also an operation which is capable of delivering goods or medical supply, food or water to areas that might not be reached anymore on ground. So we are investigating the use of drones for this kind of delivery operations. And as this kind of operation brings certain risk, we also want to bring another technology that we started to develop over the last year at DLR. And here you can go to the next slide. And this is actually the detection of people from aerial imagery. On this example, you see an aerial image acquired from a helicopter over a music festival a couple of years back. And you can see that with the use of AI algorithm, we can actually already quite accurately count, for example, the number of people in the scene. If we have now also image sequences, you can click one more time. We cannot even detect people, but we can also track them over a certain time. The difference here is now that these results that we obtained, they were computed on the ground. And the novelty that we want to investigate now for Drones for Good is to bring this AI algorithm on board of the drone. So at DLR, we also have you can go to the next slide. We have a research helicopter called Super Artist. And for this helicopter, which you see here in the video, we can equip it with a specific device, which is capable of then taking such boxes and can carry these boxes to specific regions, and also is capable of dropping these boxes by flying. And as these missions bring certain risk to people that are might on the ground, we will bring our camera system on board of the drone and also our AI. And that in the moment that before the drone will drop this package, we will scan the area below the drone, and we will make sure that no one is in danger. So that at this point, the helicopter or the drone would only drop the packages really no one is on the ground and could be damaged or it could get in danger. And this is the second scenario where we try to use AI algorithm to make this whole drone operation safer.
Okay, so and how technically, how practically would then this be done? That the AI or the deep learning algorithm actually detects the something in the area, and how does it concretely make the mission safer?
Yeah, it makes the mission safer in a way that we are trying to reduce the ground risk by operating the drones. So when we are, first of all, when we have up-to-date map information, where we know already where we have maybe critical infrastructure or where we have areas where we have a lot of people in the scene, we can avoid flying over these areas with our operation. And then the second point is that if we really scan everyone in real time on board of the drone, we can really avoid to drop anything close to someone on the ground.
Okay, no, that makes sense. And is it being done automatically that the AI system stops dropping from in the drop zone, or is that done still manually? Do the systems, flight control and the AI safety detection, are they closely integrated, or are they still operated manually and separated?
Yeah, I mean, we are still here having this research project. So the focus of the project is, first of all, to investigate if their AI is really safe enough to reliably detect people on board. So right now at the state, we will not let the AI make any decisions. So at the end, we will send the information that we compute in real time on board. We will send it to the ground station, and the drone operator will get this information and can use it. So at the end, during this project, a person will take over the decision of dropping the package in the end.
Okay, thank you, Nina, for these insights into drones for good. And with that, I would like to hand over and pass over to Armin Wedler. Armin, actually, we've heard from Nina how they operate drones, like flying drones beyond line of sight. Now you're thinking and actually working on automating and teleoperating humanitarian food supply trucks on the ground. So I learned also in cooperation with local drone observations, and that sounds very interesting. Tell us about that, Armin.
Yeah, thank you, Stefan, for the introduction words, and thank you also, Hans-Jörg and Pascal, for making this possible. I mean, so financing such an approach here. So yeah, it fits exactly the topic of teleoperated trucks and drones for scouting to my previous talks. So I think the vision we have here is the idea we developed finally initially for next planetary exploration missions. So what you can see here is a cooperative exploration scenario envisioned for the next planetary missions, where rover and maybe a scouting drone, or for example, Mars 2020 and Perseverance rover, you're all aware of because it's in television now, it's just landed on Mars by NASA, have a helicopter. So a cooperative scenario of robotic assets will explore the planetary surface. And we in AHEAD, we try to bring this technology we have developed for this application case of space research to the humanitarian sector, to the, well, we do a technology transfer because we believe that where humans are in danger, where humanitarian aid organizations are in danger, it would be beneficial to have teleoperated robotic assets which bring more than a flying drone can transport, for example. So the drone is limited by payload, a certain amount of payload. Even aircraft, so the concrete scenario we have here is aircraft delivery. We are cheaper than aircrafts, and we are probably more capable of transporting things on the ground. And what we use for technology, so which fits exactly to Nina's talk, so we have a certain way of autonomous operating such drones, and we have a mapping, we have a fully integrated system which is enabled to detect the environment, to segment the environment and detect humans and not harm any humans, which is the most important part on our track. Stefan, can you switch to the next slide, please? So let me give you a very quick and rough update of what we have here. So for situation awareness and for, let's say, the general situation of where this delivery should take place and where is the danger part, we use the technologies which were just provided by my previous presenters. So we have the organization of DLR, which is capable of using satellite imagery or even drone imagery, as you can see it here in my visionary pictures of UAVs and satellite imagery, which will be compiled as it is done in Houston, in a control room, in a space control room. So they compile the data and they plan the mission. And from this main control room, let's say, we are connected to a local control room. So that's envisioned by this container. And this local control room is in the vicinity of the last dangerous part where humanitarian transportation needs to be transported or needs to be applied to. And we believe that this last mile of delivery is the main challenge for the delivery in its own. And this should overcome the danger for the operators, for the drivers of such trucks, and for the drivers of operators on ground on the field. And I would like also to say and mention at this moment that first of all, we have great cooperation within DLR. So we have several DLR institutes. It's not only the robotics. So the main technology, I would say, comes from the robotics, but we are working with transportation. We are working with Earth observation, so your institute and my previous talkers. But we are also working with external partners. Of course, we have a main application case provided by the WFP, so World Food Program, give us a scenario, a real scenario, which is important to me to say, like we have this case where the shared vehicles, which are almost look like space rovers, right? Don't they? And they have a case which is in South Sudan. And looking at the actual situation, like the pandemic situation is challenging for all of us. But of course, in those areas, the dangers even increased much more. And we believe that this real scenario brings us very close to the needs of the people. And that's, I mentioned by my previous presenters here, it's an important case for us because we need to transfer this technology we have for space. We know it fits to the space missions, but we don't know how to adapt it. And one key aspect of the HAT project is, let's say, to make it realistic to do such support in such an environment. And we also have spin-offs. So technology spin-off is in our days a very important one. So two of our spin-offs, which mainly work for industry, sensor drive and roboception, are supporting us. And we are using their products, which are in the market, and we apply them to this new challenge of bringing the autonomous space rover to a terrestrial application. Next slide, please, Stefan. So the HAT project, so Autonomous Humanitarian Emergency Aid Devices, envisions the idea of having a backbone project. And as said before, thanks to your activity, Stefan, and to this, let's say, idea in DLR to establish such a technology spin-off field, we could establish a backbone project, which we call the HAT. And to this backbone project, which is, let's say, just the first financing line, we are now applying additional projects because we envision really to bring this technology in operation. And of course, we would like finally to see the technology applied in the field and used in the field. But for arriving with a baseline technology towards such a goal, we need to gather money together. We need to gather stakeholders together. And of course, we need also to maybe add more help organizations, more humanitarian aid organizations. And that is envisioned within the backbone project ahead within 3-4 steps. So we envision to extend the intelligent vision we have. So we use AI technologies, which Nina have just presented. So we try to semantic annotate the environment in real time, because if we drive in it, we need to do it in real time. We want to enhance teleoperation and autonomy, also mentioned by my previous presenters. So we don't want to say that this is an autonomous operation because the scenario is so complex, the scenario is so unpredictable. So we always rely on a teleoperation manner. We want to add and assist as much as we can, but in the end, the teleoperator at the end goal will be, let's say, the guy who say yes or no to the application. And
so, I mean, but when and how are you actually planning to deploy the HAT truck then in a real crisis scenario?
Yeah, good question. I mean, the goal of this HAT framework is to develop the technology towards the field test. And that's, let's say, the last arrow here on this foil, which is envisioned in 5-6 years framework. But that's not yet a prototype. So that's a prototype, the final demonstration prototype, but not yet a project or a product for WFP. The need of WFP to have a service and to use it as a usual delivery method, I think that is an additional transfer which is needed to make it work as service, as business unit in the field, which is probably additionally 3-4 years. So 6 years ahead project I envision, and then technology transfer 3-4 years to have the service in the field.
Okay, so that's quite a visionary thing, and we are still, so say, at the start of things, but we're getting there, and it's still a ways to go. So it will not be in the field, let's say next year, but we're working on it to get it there. Great stuff. Thank you very much. And actually, that concludes the overview of the humanitarian technology projects currently being executed and worked on within DLR. And this brings us now to the actually Q&A session, where you, the audience, have the chance to provide us with some questions. Maybe there are already some in the Slido system. I give you here again the links, slido.com, and IFGNF series is the code. So please put your questions there. We have another 10 or so minutes to discuss more. And actually, now I would like to ask Vanessa, you have been following the Slido Q&A and questions. Are there any questions that the audience has posed to us and to the team?
Yes, indeed, Stefan. There are lots of questions on Slido, some technical, some more general. And I would like to start maybe with a more general overview question for, I would say, Hans-Jörg Dittus. What are actually DLR's future plans and priorities for the HUMTechs? So will you be working more with humanitarian organizations or other space partners? So what is the vision for this project for the next years after starting it in 2019? And is there maybe also something or some ideas for supporting within the Corona crisis?
Yeah, that's a good question. It's a really good question, because when we started, of course, this was the main question. What we have is seed money, to be honest. It's not a big thing. We cannot spend billions and billions, although we need them. So the idea is to stimulate by demonstration. So we looked for partners. They really need the help, and they need the technology. And the hope is that by doing this and by demonstrating that it really works, we find people, they give us more money. For example, foundations and maybe also public boards to help it, to bring it up to further projects or to more projects. But I think the first idea was indeed to give this seed money to the technology development, and hoping for more by demonstrating that it really works. So this is the idea. And so far, we are starting this kind of conversation with foundations, also with other partners. And the other idea is that we stimulate also to come to private initiatives like founding of companies. They take over in a private engagement paid by the public to do this kind of services. So we are not the service partner with respect to running the drones or running the cars and or these lorries. We are technology provider, and we are looking for people. They take over and say, okay, we do it. We make these transports. We make this based on this technology. So it's a combination of public and private money we are looking for at the end, and private initiatives we like to stimulate.
Okay, thanks, Hans-Jörg. maybe directly coming to that issue of the last mile you have to get, and actually the financing issue. There was one question for Daniel, the Meepa project. So how much does it actually cost to set up one of these, I say, salad boxes? And is there any issue regarding climate challenges, dry areas, wet areas?
Yes. Thank you. So the prototype that we are developing right now will, of course, be in the pure production perspective, of course, quite expensive. I would say in the range of a couple of €1,000. But this is important. We have to do this and we have to test it in the field. So the idea is to develop it, build it first time, go in the field, do testing, getting knowledge from that, getting lessons learned from that, and then going back and doing a better system that is more cost effective. And then the second generation will already go in this direction. In the end, such a system should not cost that much. We are really talking about mass deployment. So really we have to aim for, let's say, a production cost of perhaps a couple of €100 to make it feasible later on, to really deploy it. We were thinking, my vision is to have thousands of them in a refugee camp. So every family there can have their own small garden to produce some lettuce and tomatoes. So the goal will be, in the end, when we finish it, to have a production costs of perhaps 100 or 200, 300 euros.
Okay, thanks. So maybe one question also for Anna in the Data for Human project context. There was one question regarding the internet issue. What happens if you have no connection in the area the people are actually working? You said the information will be provided as a web service. Are there any other boundary conditions regarding internet? And in general, how do you see the future of the internet and social media information for developing a humanitarian situational awareness product in the future?
Okay, thanks. Yeah, there are a couple of questions in there. First of all, the challenge with web data is huge. So not only we have to make sure that the web data we harvest, let's say it like that, is reliable and geolocatable, but we also have to assess it in different languages. So, for example, the case study of Mozambique is such a challenging area because people there hardly Twitter in English. And this is already challenging. And then, of course, the access to those platforms. So we have, but you know, in the United States or in Europe, it would be easy. So we don't want it to be easy. So we make it in such an area. And so we want to try to find out, is it possible at all to use web data in these areas, and not only talking about Twitter data, but also talking about weather forecast or tsunami warnings and so on. I think the second question went in a bit of a different direction about the access on our web services, right? Yeah. So we had lots of discussions with users about how to provide our data in the best way possible. And considering that we have different users with different technological abilities, so some of them do all the programming themselves, some of them need ready products, we had to find a kind of a good way to provide them all with our information. And this is the first step. So the first step was to use a web service, let's say a web mapping service or a web coverage service, so that that the users can either only visualize the product or overlay their own products with our products, or they can even download the data with that web service and use it for further analysis. So that was for us kind of the best way at the moment to provide all of the people with this service. But you're right, so the access on the ground is a big issue. So of course, we cannot make our data hundreds of gigabytes big. So we try to keep it as simple as possible, that even with a little internet connection, you can still kind of visualize the data. And that was the last question. Oh yeah, am I allowed to answer this as well?
Quickly, yes.
Yes, okay. So web data, it has a huge potential. And what we are currently aiming for is actually to use it for a kind of a monitoring. So just consider you have a time series of satellite data, and within the satellite data, you see there are anomalies. So this triggers you and you see like, okay, something's going on there on the ground, a flood, an earthquake, or whatever. But sometimes this time series is not very dense. And this is something where web data can help us. So web data can complement this. And even in web data, you might see some anomalies like, oh my God, the earth is shaking here, or the water is coming, which then can trigger us as product providers to support the relief actions with quicker products. So that was very, very short.
Okay, yeah, thank you. So then pass a question maybe to Nina for the drones for goods. There was an issue regarding a question regarding real-time AI processing on the small drone systems, and that you really make sure that you don't drop anything when there are humans on the ground. And I actually had to smile a bit when watching your video because I saw a bird flying next to the drone. And I thought, okay, you detect the humans, but what happens with the animals? So maybe what are the challenges regarding the AI processing framework near real time on these small devices?
Yes, thanks for your question. Of course, we are facing several challenges by trying to bring this AI on board of a drone. For example, we have power consumption limitation, but most important is basically that we have computational limitations. So like if you have like a normal AI algorithm that you have on your workstation, you have GPUs that can even handle really complex models. But if you try to bring this on, like if you need an embedded GPU on board of the drone, and for this, we somehow have to reduce the complexity of our model in order to really process the data in real time. And the challenge here is that we lower the complexity in the model in such a way that we don't lose all the performance of the model, and that we can really make sure, especially in this case, that the model is so good that we really detect all the people on the ground. And these are the challenges, the main challenge that we're facing.
Okay, thanks. Maybe a last question from the Slido questionnaire for Armin. This was a question regarding how do you actually act in remote areas in case of failures of engine or other components? What happens then? What do you do?
In case of mechanical failures of the truck itself, in terms of such a system, well, I mean, we cannot probably remotely repair the engine of the truck. So if the engine of the truck fails, we need to send out a emergency service, I would say. So that's not our challenge in terms of tele, because the truck is a system we got from the World Food Program, which is provided by a distributor. So we're not developing the truck itself. We're developing the intelligent algorithm to teleoperate it and to perceive the environment and to predict what to do. So if cases like communication losses or something like in our direct communication line happens, we have failure capturing strategies and failures, but for failure in the mechanical manner of the vehicle, we need to call the ADAC for humanitarian areas. I'm sorry. Okay. Does it answer your question, or was it meant in another direction?
No, well, I only see what is asked on Slido. For me, you answered.
I hope it answered. Yeah. I don't know. I think we're running out of time, so we should.
Maybe we can have one more question from the Slido, and yeah, Vanessa, can you read another final question for us?
Yeah, maybe one question for you, actually. Now we have the Corona situation. What kind of project would you initiate in the Corona situation in the Humanitarian Technology project framework? Is there any idea you have for future next projects, maybe targeting the Corona or other societal challenges?
Well, we started out in the very first moment when Corona was on more or less starting a year ago, and discussed among the different members of the projects and network, and thought where can we come in and help? But of course, that turned out there were small little pieces here with some algorithms that we could use to sort of follow certain things on the web, and also some analytics. There were some things being done, actually some GIS developments to support overview on hospitals and these things like capacity and stuff. So that developed and is even going operational now. So that spun off partially from the HumTech initiative. Of course, now with all that humanitarian needs, these humanitarian needs being increased and aggravated through the Corona crisis, a lot of problems are in interruption of logistics and interruption of supply chains, and that's something where we should all as a community think on where we can help with our technologies, with our experience, with our networks to help the humanitarian players really cope with these logistics and supply chain issues. So we're in discussions, but there's no one single project right now that I could mention that is really the thing to cope with Corona. Corona is a global aspect, but we should try really here and there wherever we can to support the work that's done. And yeah. Okay, so we're at 1500, so that means that this panel and this session is coming to a close, and I would actually like to hand over to Hans-Jörg for a final statement and a farewell.
Okay, thank you very much. I hope it was an interesting hour, and I'd like to thank again IAF for giving us this opportunity to present what we have developed as ideas and as technologies in the last 2 years. And I hope that what we have presented here will find some echoes outside, and everyone who is interested to work together with us, of course, is invited to come with his or her ideas to us. And whenever we can, we like to develop with you and with your with our partners the future, and hope that we can stimulate with this campaign more technology transfers from space to ground. And if this will work, this was a nice hour. And I wish you a nice day and a nice ongoing conferences here. Thank you very much from my side.
Thank you.
Thank you.